So I wanted to give you guys a couple more examples out of 4.3. If you remember from 4.1, the degree of the polynomial, meaning the highest exponent, that's the number of roots or zeros or solutions. All of those mean the same thing. So for instance, if you have x to the fourth power, means that you're going to have 4 solutions. Also, another theorem out of this section, if a plus bi is a solution, so a complex number, then a minus bi will also be a solution, meaning the conjugate will be a solution. So we're going to use those two things in these next two examples. So here's our first example. We have find the standard form with a degree of 3. Now right off the bat, that degree of 3 tells me that I should have 3 solutions because of that degree rule that we learned in 4.1. This is also number 6 in your textbook. So on page 269, if you want to follow along, it's number 6. So find a standard form with the degree of 3, meaning that there's 3 solutions, and they gave me 2 of them, x equals 0 and 4 minus 3i. So I'm going to fill out my chart. So I have x equals 0, x equals 4 minus 3i. Those were 2 that were given. And then the last one I'm going to get out of the conjugate zero theorem, which says that if 4 minus 3i is a solution, then it's conjugated as well, which means change the sign of I. So I have 3 solutions, x equals 0, x equals 4 minus 3i, and 4 plus 3i. And again, the first 2 are given, the last one came out of the conjugate zero theorem. So now I need to get these whole zeros in factored form. So I need to get them in parentheses, all equal to 0. That's my goal. So I just solve for 0. Well, x equals 0 is already done, so the factor is x. Now with the 4 minus 3i, if I minus 4 from both sides and add 3i, then I'm going to get x minus 4 plus 3i as my other factor. Same thing with the last one, minus 4, minus 4, minus 3i, minus 3i. So it's kind of like I'm moving everything over to the left. So those are my 3 factors. Now that they are all equal to 0 versus before they were equal to 4 minus 3i and 4 plus 3i. Now that all of these are equal to 0, I can stick them in my big, long, factored out form, and then I'm going to undo factoring, which is foiling. So it's going to be a lot of algebra. So I'm going to take all of these things and stick them into an equation. So I have all of these, which will give me x times x minus 4 plus 3i times x minus 4 minus 3i. And then all of that equals 0. So now this is a whole bunch of foiling. I always start at the back, and so I'm going to FOIL the last 2 terms. Now if you remember in class, we talked about this little shortcut. This thing right here, that is your shortcut for multiplying things that look like that. If you don't do the shortcut, you have to multiply x times everything, so x times x, x times a, x times bi, a times x, a times a times bi, bi times x, bi times a, bi times bi. So you have to do a lot of distributing, versus if you just know this formula, it kind of gives you a shortcut. So I need to pull out my a and b, and my a and b comes from the zeros in this left column. It comes from standard form. So standard form being a plus bi, meaning that 4 is going to be my a, and b is going to be 3 or negative 3. Now because b is going into b squared, going into that formula, it doesn't matter if you use the positive or the negative version. But yes, there are 2 b's. I always pick the positive one because it just makes your life a little bit easier. So I have an a of 4 and a b of 3. I'm going to plug that into this formula, this thing right here. So I have x squared minus 2 times a, well, a is 4, times x, plus a squared, which is 4, plus b squared, which is 3. Now this is just a matter of putting all of that in your calculator. So just going through and simplifying, I have x squared, 2 times 4, or negative 2 times 4 gives me negative 8x. And then the 4 squared gives me 16, 3 squared gives me 9. So I'm just multiplying through. Now these last two are like terms, so I'm going to go ahead and combine those to be positive 25. Now do not think you're done. I still have this x that's hanging out front. So that thing's going to fall all the way down. And now I need to multiply that thing. Now because x is just one term, I don't actually have to FOIL or do double distribute. I can just do one single distribute because there's not like an x plus 3 out front. So I'm going to distribute, which will give me x cubed, distribute negative 8x squared, distribute 25x. And so that is my final answer. And in the directions, it said that the leading coefficient was going to be 1, so that means I don't have to do any changing of the leading coefficient at the very end. So here is your final answer. Alright, so last example. This is example 5 in your notes. So if you want to follow along in your printed out notes from class, you can. We didn't get to it in class, so we're finishing it up here. So this one, before they wanted me to find the standard form, they wanted me to find this thing. Here they give me standard form and they say that they want me to find the zero. So I'm kind of going the opposite direction. So if you remember, with finding the zeros, you're going to go through and just do synthetic division on these. So with synthetic division, I'm going to take the first 0 that they gave me, 4, put it in my box. It does not change signs. It only changes signs if it's attached to an x, so if they give you the actual factor. Because here they just told me the factor, I just go straight through and start my synthetic division. So I take the coefficients 2, negative 1, negative 27, positive 16, and negative 80. Now I'm going to carry down the first one, and remember I multiply on the diagonal, so 4 times 2 gives me 8. Once I get them lined up in the column, then I add. So negative 1 plus 8 gives me 7. I'm then going to multiply on the diagonal and get positive 28. 27 plus 28 gives me positive 1. Multiply on the diagonal, so I get 4 times 1 gives me 4. 16 plus 4 is 20. And then 4 times 20 gives me 80, add them, which gives me 0. So if you remember that last thing over there, that's your remainder. With these in 4.3, you'll always get a remainder of 0 because these are zeros, so they are dividing evenly every single time. So now that tells me that here is my next equation. So if you remember, they go from synthetic division, it decreases 1 degree. So now I have 2x cubed plus 7x squared plus 1x plus 20. Now normally I would, once I did synthetic division, I'd be left with an x squared term, which x squared terms I can do the quadratic formula. I can't do that yet because I still have 4 terms and it's x cubed. So I'm going to have to do synthetic division again, and I'm going to do it with the other 0, so the second 0. So I've got negative 4 in my box, and now I'm going to use the coefficients of the problem up above. So these coefficients are going to be the ones to fall down. So I'm going to do the same thing again. Now notice in my box is the other 0, the negative 4. So I carry down my 2. Negative 4 times 2 gives me negative 8. 7 plus negative 8 gives me negative 1. Negative 4 times negative 1 gives me positive 4. 1 plus 4 gives me 5. Negative 4 times positive 5, negative 20, which gives me a remainder of 0. So now, here's my next equation. And finally, it's an x squared term, so that means now I can go through and do the quadratic formula. So I have b squared minus 4ac first. So now that I've found my discriminant of negative 39, I'm going to plug everything into the quadratic formula. So once I plug it into the formula, I get 1 plus or minus I square root 39 all over 4. Now, if you remember, the plus or minus means two separate answers. So one answer is 1 plus I square root 39 all over 4. The other answer is 1 minus I square root 39 over 4. So those are my two missing zeros. They gave me 2, and I had to find the other 2. And I use synthetic division, and I keep dividing until I get it down to a quadratic, and then I use the quadratic formula.